Okay, let's unpack this. Imagine an AI model so fast, it has hundreds of billions of parameters, but when you ask it a question, only a tiny fraction, maybe just tens of billions, actually wake up to give you the answer.
Right.
How does it do that? And maybe more importantly, what does that fundamental change mean for how AI gets built, used, and who gets to control it?
Well, that efficiency secret, that's a huge piece of what we're calling the new wave of open source AI. It's a really exciting area.
It really is. And today we're doing a deep dive into a stack of sources you've shared, articles, research, our notes that seem to cut right to the heart of this, well, transformation.
Yeah, and it's important to stress, this isn't the open source many people might remember from, say, decades past, like Linux for operating systems or maybe TensorFlow for building machine learning models.
Right, those were tools, powerful tools, absolutely, but still tools.
Exactly. This new wave, it's different, fundamentally different. It's about sharing the actual trained intelligence.
The model weights themselves.
Precisely. It's like getting the blueprint and the finely tuned engine, not just the factory floor plans and machinery. You get the finished product, you're close to it.
And that shift from just open tools to open trained intelligence, that feels like a seismic event. Like it's dramatically lowering the barrier to entry.
It really is. It's essentially democratizing access to AI power that, honestly, just a few years ago was the exclusive domain of a handful of very large, very well-funded companies.
So our mission for this deep dive, then, is to understand how these open source foundation models are reshaping, well, everything. Technology, business models, even global power dynamics.
Yeah, we'll look at the technical magic making it possible, that efficiency thing and more, and, try to peek at what might be coming next down the line.
Okay, first things first, though.
Yeah.
We need to get really clear on what open even means in this AI world.
Yeah.
Because it sounds like it's definitely not just one simple thing.
That's absolutely critical. It's a spectrum, not a switch. Openness in AI exists on a, continuum.
Okay, so what's at one end? The most open end.
That's where you find the fully open models. Think licenses like Apache 2.0 or MIT. Super permissive.
Example.
Models like Mistral 7B, Microsoft's Phi 3.5 mini instruct, or many from Alibaba's Qwen family fall into this category.
And permissive means?
Use them for pretty much anything. Commercial use, modify them, share them, usually just asking for attribution, like saying where you glean it. Apache 2.0 is particularly good because it's very clear about patent rights, which is important for businesses.
Okay. Truly open, minimal rules. Got it. What's in the middle of this spectrum?
That's where things get, let's say, more nuanced. These are models with use restrictions. Here, you typically get access to the weights and the code, which is huge, right? You can see inside, run it yourself.
But there's a catch.
Exactly. The licenses come with strings attached. And the prime example everyone points to here is Meta's Llama series. Llama 2, Llama 3.
Ah, yes, Llama. That's the one with the usage limit, right?
Yeah.
Something about how many users you have.
Precisely. The Llama 3 license, for instance, allows broad use, which is great, but it explicitly says you can't use Llama models to improve other large language models unless they're also Llama derivatives.
Okay, so you can't train your competitor using their model. Makes sense.
Right. And the really big one, if your product or service that uses Llama hits 700 million monthly active users, MAUs, you suddenly need a separate negotiated commercial license directly from Meta.
700 million users. That's a high bar, but it's definitely a restriction. It means it's not free for everyone commercially at the highest scale.
Exactly. And that specific restriction is a major reason why some groups, like the Open Source Initiative, the OSI, don't consider Llama to be truly open source based on their traditional definitions. Those definitions usually emphasize freedom from that kind of commercial scaling limitation or field of use restriction.
So Llama is source available or community licensed, but maybe not OSI approved open source.
Yeah.
Nuance matters.
It really does. And you see other models in this middle ground too. DeepSeek, for example, uses a dual approach. Their code might be under a permissive MIT license.
Okay.
But the actual model weights, the intelligence part, are under a custom license. It's based on something called OpenRail. And it allows commercial use, but it mandates that anyone who uses or modifies the model must also pass on the same use restrictions.
And what kind of restrictions are those?
Things like prohibiting military applications or use for generating harmful content, illegal activities, that sort of thing. So again, access is granted, but it's not for absolutely any purpose.
Got it. So fully open, restricted use.
Yeah.
What's at the other end? the least open.
That would be what you might call open access proprietary models. Here, everything is closed internally. You never see the code. You never get the weights. It's a black box.
But you can still use it.
Often, yes. The developers might let you interact with the model, usually through a public API. Think early free access to models like ChatGPT or free tiers offered by various companies. You can use its capabilities, send it queries, get responses.
But you can't look under the hood. You can't modify it. You can't run it on your own servers.
Exactly. The developer retains full control. You're just using it as a service.
Okay, that spectrum makes sense. Truly open weights, weights with restrictions, and just API access. And the OSI, you mentioned, is trying to formalize this for AI.
Yes, they've been working on definitions. Their drafts, like one from August 2024, lean towards requiring free access, modification, and sharing for any purpose. That includes access to the source code and the training weights. Interestingly, though, not necessarily the training data itself. That's often kept separate.
Right. The data is a whole other can of worms.
And it's really clear from looking at the landscape and, our sources that for some companies, this strategic openness, that middle ground with restrictions, is a very deliberate competitive play. Well, it lets them build a huge ecosystem around their model very quickly. It challenges the established proprietary giants like OpenAI or Anthropic. It gets broad adoption from developers and researchers. But they still keep a degree of control, especially over very large-scale commercialization or use in certain sensitive areas. It's a balancing act.
Makes sense. Okay, spectrum defined. Let's pivot now and take that global tour you mentioned. This really isn't just a Silicon Valley story anymore, is it?
Not at all. It's truly global. We've got major players making significant moves all over the world.
Where should we start? Maybe the US, with Meta.
Sure. Meta's Llama series is undeniably a foundational force in this space. Llama 1's accidental leak kind of kickstarted a lot of the community momentum, even if unintentionally.
Right. The leak that showed what was possible.
Exactly. Then came the purposeful releases of Llama 2 and now Llama 3. Llama 3 is technically very strong, trained on a massive data set, over 15 trillion tokens apparently, pushing state-of-the-art performance on many standard benchmarks like MMLU, Human Eval for coding, GSM 8K for math.
And they're adding capabilities too.
Yes, Llama 3.1 and 3.2 are bringing things like significantly larger context windows and, crucially, multimodal capabilities with Llama 3.2 Vision, so it can understand images too.
And their target audience. Still developers, researchers?
Primarily, yes. Researchers, developers, startups, they even have a Llama startup program and enterprises, but always with that asterisk of the custom license and the MAU restriction for very large-scale use.
Okay, Meta in the US. Let's hop over to China. Alibaba seems like a major player there with Qwen.
Absolutely. Alibaba's Qwen series, also known as Qwen, is incredibly diverse. They have a huge range of models. General purpose ones, MoE variants like Qwen Max Mo, specialized models for coding, math, vision language, VL, even audio.
A whole family. What's their latest push?
The Qwen 3 family, released around April 2025, is notable. It includes both dense models and sparse MoE models. But their really big claim, their differentiator, is the massive multilingual training.
You mentioned this earlier. How many languages?
Qwen 3 was reportedly trained on a staggering 36 trillion tokens across 119 languages and dialects.
Wow, 119. That's huge for global reach, especially outside the English-speaking world.
Definitely. They also claim competitive performance against models like GPT-4o and Llama 3.1 on benchmarks, long context windows up to 128K, strong multimodal abilities, and specialized models like Qwen Coder trained on 92 programming languages.
And the licensing for Qwen.
This is interesting. Many of their models, including the Qwen 3 family, are released under the permissive Apache 2.0 license.
So genuinely open source for many of their key offerings.
Yes, though some of their other or older models might have different or proprietary licenses. But the trend with Qwen 3 seems strongly towards open. Their target is global, especially where multilingual capabilities are key, and for specialized needs like coding or math.
Okay, staying in China, what about Baidu and ERNIE?
Baidu is another heavyweight. Their main series is ERNIE. ERNIE 4.5 is their current flagship, a multimodal generalist model. They also have ERNIE X1, which they position for deeper reasoning and tool use.
And how does ERNIE stack up, according to Baidu?
Baidu makes some bold claims. They suggest ERNIE 4.5 surpasses GPT-4o on some multimodal benchmarks and is slightly ahead of models like GPT 4.5 or DeepSeek V3 on some text tasks. They particularly emphasize its strength in Chinese language benchmarks, which makes sense.
And cost.
That seems to be a major angle for Baidu. They claim ERNIE 4.5's API pricing is incredibly low, potentially just 1% of what GPT 4.5 costs. That's a massive potential disruption if the performance holds up.
1%. That's aggressive.
And licensing. This is recent news. Baidu announced that ERNIE 4.5 would become open source as of June 30th, 2025. The exact license details were still pending when our sources were compiled, but that's a significant move, making another powerful model potentially widely available.
A major Chinese tech giant releasing its flagship model.
Interesting. Now, what about DeepSeek? They're a startup, right? But they've made a lot of noise. Yes, a startup founded by a co-founder of Highflyer Quant. They've released a suite of models. DeepSeek R1 focused on reasoning, V3 as a base model, plus specialized coder, math, and vision language models.
What are their key claims to fame?
R1's strong reasoning performance, supposedly rivaling models like OpenAI's O1, is a big one. They achieved this using reinforcement learning on a base model called R10. They also use ENMOE architecture. Their R1 model has 671 billion total parameters, but only activates 37 billion per token, making it efficient.
The MOE efficiency again.
Exactly. They also highlight very cost-effective training, claiming their V3 model cost around $5.6 million to train, which is dramatically less than the estimated $100 million for something like GPT-4. Their coder models also perform very well on benchmarks like Human Eval.
Okay, impressive performance and efficiency claims. But you mentioned controversy earlier.
Yes, the training data provenance issue. There have been allegations and some documented instances where DeepSeek models, particularly R1, seem to identify themselves as being developed by OpenAI or exhibit other behaviors suggesting they might have been trained, at least in part, on outputs from proprietary models like those from OpenAI or Microsoft.
Ah, the digital cannibalism concern we might touch on later, using one AI's output to train another.
Precisely. It raises complex ethical and legal questions about intellectual property, violating terms of service, data originality, and the pressure to achieve top benchmark scores quickly. It's a murky area in the open ecosystem right now.
And their license reflects some caution.
Yes, that dual license code is MI2, but the weights are under their custom DeepSeek model license based on OpenRail. It allows commercial use, but crucially, mandates passing on those use restrictions, no military use, no harmful content generation. So it targets developers and researchers wanting cutting-edge reasoning or coding, but with guardrails attached.
Okay, let's shift back towards Europe. Mistral AI in France. They've been seen as a European champion.
Absolutely. Mistral AI has been hugely influential. They really pioneered making a mixture of experts accessible and performant in the open source world with their Mixtral 8x7b model.
That one made big waves. Showed MOE wasn't just a theoretical thing.
Exactly. It outperformed models like Llama 270b and GPT 3.5, despite being much more efficient to run. They've since released larger MOE models like Mixtral 8x22b, and their Mistral Large 2 model with open weights was initially second only to GPT-4 at launch on some benchmarks.
So top-tier performance from efficient architectures.
Yes, and they're expanding. Pixtral is their multimodal offering, combining vision with Mistral Large 2. They also have specialized models, CodeStral for coding across 80-plus languages, MathStral for math, and DevStral, which is more agentic for development tasks.
What about their licensing philosophy?
They've been strong proponents of true open source. Many of their core models, Mistral 7b, the Mixtral models, MathStral, DevStral, Mistral Small 3.1, are released under the permissive Apache 2.0 license.
That's significant for the community.
It is, though some of their very latest or specialized models might have more restrictive licenses, like a non-production license for CodeStral initially, or research use licenses for Pixtral and Mistral Large 2. They also offer proprietary API access like others. But their core commitment to Apache 2.0 for many powerful models makes them a key player, especially appealing within the EU context of seeking digital sovereignty.
Makes sense. Anyone else we should quickly mention in this landscape?
Definitely worth noting Stability AI, primarily known for leading open image generation with Stable Diffusion SDXL, SD 3.5, Stable Image Ultra. They're also in audio with Stable Audio Open. Their licensing is often a community license, free for smaller entities but requires payment or has non-commercial restrictions for larger ones.
So more of that middle ground licensing.
Right. And Eleuther AI, the U.S. nonprofit, they're focused on research, understanding large models, and ensuring access. They've been behind foundational projects like GPT-Neo X, datasets like the Pile, and contributed to early open models. They typically use permissive licenses like Apache 2.0 or MIT, championing open and ethical AI research.
And the big players, Google and Microsoft, they're mostly proprietary, but they dip their toes in open source.
Exactly. It's strategic for them. Google has the Gemma family, Gemma 2B, 7B, and the newer Gemma 3, which is multimodal. These are built using similar techniques as their proprietary Gemini models. Gemma 3 boasts a 128K context window. Google uses an open weights license that does allow commercial use.
And Microsoft.
Microsoft has the Phi series. Phi 2 gained attention, and now they have Phi 3.5 Mini Instruct, a surprisingly capable small model of 3.8 billion parameters, multilingual, with a 128K context released under the MIT license. They also have Phi 4 multimodal, focused on being compact and efficient for edge devices, also open source.
Why do these giants release open models?
Several reasons. It engages the developer community, allows them to set standards, especially for smaller, efficient models, gathers valuable feedback, and ultimately can help drive adoption of their cloud platforms where these models can be easily deployed and fine-tuned. It's smart ecosystem building.
Wow, okay. That's a truly global and complex landscape of players and models. But you keep mentioning efficiency. How are these models, especially the open ones, achieving such high performance without necessarily needing the absolute colossal nation-state level compute budgets that we associate with training the biggest proprietary models from scratch?
That really gets us into the technical deep dive. Efficiency is the name of the game. And the technique we started with, mixture of experts, MOE, is absolutely central to this story.
Right, the choose-your-own-chef's idea. Can we break that down a bit more?
Sure. So imagine inside the model, instead of one giant monolithic network, you have multiple smaller specialized subnetworks. These are the experts. Let's say there are 8 or 16 or even 64 of them.
Okay, multiple mini brains.
Kind of. Now, for every single piece of input that comes into the model, typically a token, which is like a word or part of a word, there's a small router network.
A traffic cop.
Exactly. The router looks at the token and quickly decides, okay, for this specific token, I think expert 2 and expert 5 are the most relevant. It then sends the token only to those selected experts for processing. The other experts remain dormant for that token.
Ah, so not every part of the model fires up for every single calculation.
Precisely. This means the model can have a massive total number of parameters representing a huge potential capacity and knowledge store. DeepSeek R1, for example, has 671 billion total parameters. That's enormous.
Bigger than GPT-3.
Significantly. But for any given token, only a small fraction of those parameters are actually activated and used in the computation. For DeepSeek R1, it's about 37 billion active parameters per token. For Mixtral 8x7b, it has about 47 billion total parameters, but only activates around 13 billion per token.
So you get the knowledge capacity of the huge parameter count, but the computational cost, the speed and energy use during inference, is closer to that of the much smaller active parameter count.
You've got it. It allows for scaling up model capacity without a proportional increase in inference cost and latency. It's a key enabler for getting high performance more efficiently. And there's ongoing research, like MOFE, mixture of fine-tuned experts exploring variations.
Super clever. Okay, MOE is one big piece. What else is making these models lean and mean?
The next big area is model compression and quantization. Foundation models, even efficient MOE ones, are still often too large to run easily on standard hardware, let alone edge devices, so you need to shrink them.
How do you shrink an AI model?
Quantization is a primary technique. It's about reducing the numerical precision of the model's weights, those parameters we keep talking about. Normally, these weights are stored as high-precision floating point numbers, like 32-bit floats, FP32, or maybe 16-bit floats, FT16.
Okay, left the decimal places.
Right. Quantization converts these high-precision numbers into lower-precision formats, most commonly 8-bit integers, INT8, or even more aggressively, 4-bit integers, INT4, or sometimes even lower, like 2-bit or 1-bit in research.
You mentioned the analogy of using fewer colors to paint a picture. You lose a little detail, maybe, but the file size gets much smaller.
That's a great way to think about it. You trade a tiny bit of numerical precision for significant gains.
Like what?
Much smaller model size on disk and in memory. Faster inference speed, because calculations with lower precision integers are generally faster on modern CPUs and GPUs. Lower energy consumption. And it's absolutely essential for deploying models on resource-constrained devices like smartphones or IoT hardware.
So quantization is key for edge AI and just general efficiency.
Yeah.
Are there different ways to do it?
Broadly, yes. There's post-training quantization, PTQ, where you take an already trained model and convert its weights afterwards. This is simpler, but might lead to more accuracy loss, especially at very low bit rates like INT4.
And the alternative?
Quantization-aware training, QAT. Here, you actually simulate the effects of quantization during the model's training process. This allows the model to learn to be robust to the lower precision, often resulting in better accuracy preservation, especially when pushing down to INT4 or below. It's more complex to implement, though.
Right. Let's do that expert pit stop you suggested. Can you dig into the trade-offs between, say, INT8 and INT4 quantization? When would you choose one over the other?
Okay, sure. So INT8 quantization is pretty much a standard practice now. Going from FP16 or FP32 down to INT8 typically cuts the model size roughly in half and speeds up inference significantly, often by 2x or more depending on the hardware. The great thing about INT8 is that the accuracy drop is usually minimal, often negligible for many tasks. Most modern CPUs and GPUs have good support for INT8 computations, making it relatively easy to get these benefits. It's kind of the default first step for optimization.
Okay, so INT8 is common, effective, generally safe for accuracy. Why push further to INT4?
The allure of INT4 is another doubling of efficiency. An INT4 model is roughly half the size of its INT8 counterpart and potentially faster still. This is huge if you're targeting very constrained environments like low-power edge devices, mobile phones where every megabyte of RAM counts, or trying to fit larger models into limited GPU memory.
But there must be a bigger trade-off.
There usually is. The potential for accuracy degradation is significantly higher with INT4 compared to INT8. We're using only 16 distinct values to represent the weights versus 256 for INT8. This requires more care. As mentioned, QAT often becomes more important for good INT4 performance. Also, hardware support for INT4 inference isn't quite as widespread or mature as for INT8 yet, although it's improving rapidly. So you choose INT4 when you absolutely need that maximum compression and efficiency, and you're willing to potentially invest more effort in the quantization process, like using QAT, and carefully validate the performance to ensure the accuracy drop isn't too severe for your specific application. It's about pushing the envelope further, but with more risks to manage.
That makes sense. It's a classic engineering trade-off, size and speed versus potential accuracy loss and implementation complexity.
Exactly. And quantization isn't the only compression game in town. There's also pruning, which involves removing redundant or less important weights or even entire neurons from the network, making it sparser and smaller. And knowledge distillation, where you train a smaller student model to mimic the behavior of a larger, more capable teacher model. This is great for creating highly specialized, compact models.
Like distilling a DeepSeek R1 down for a specific task.
Precisely. These techniques, often used in combination, are crucial for making powerful AI accessible.
Okay, MOE compression. What else is in the efficiency toolbox?
Advanced training and data techniques are playing a huge role. It's not just about throwing petabytes of random internet data at models anymore. There's a growing focus on highly curated, high-quality data sets.
Quality over quantity.
To some extent, yes. Especially creating data sets that are dense in reasoning, logic, or specific skills you want the model to learn. Microsoft's Phi models were early examples of showing great performance from smaller models trained on carefully selected textbook quality data.
Interesting. And adapting models.
This is where parameter-efficient fine-tuning, or PEFT, has been absolutely revolutionary. Before PEFT, if you wanted to adapt a huge foundation model to your specific task or data, you often had to retrain or fine-tune a large portion of its parameters, which still required significant computational resources.
Right, expensive and slow.
PEFT changes that completely. Techniques like LoRa, low-ranked adaptation, prefix tuning, or adapters allow you to achieve strong fine-tuning performance by updating only a tiny fraction of the model's total parameters, sometimes less than 1%.
You use the analogy of adding sticky notes to a huge textbook instead of rewriting chapters.
That's exactly it. You freeze the vast majority of the pre-trained model weights and just train these small additional modules or matrices. It makes customizing these powerful models incredibly accessible, doable on consumer GPUs in many cases. It's democratized fine-tuning.
Huge. Any other training innovations?
We should mention the alignment techniques like RLHF, reinforcement learning from human feedback, and RLAIF, reinforcement learning from AI feedback. These are used after initial pre-training to steer the model's behavior, make it more helpful, honest, and harmless, and better follow instructions. Models like Qwen 2.5 and DeepSeek R1 explicitly mention using these methods.
And finally, any cutting-edge prediction methods.
An active area of research is multi-token prediction. Traditionally, these models predict just the very next token, word or subword, in a sequence. Multi-token prediction aims to predict several future tokens simultaneously.
How does that help?
The hope is that it could lead to better sample efficiency during training, potentially improved reasoning and coding performance by looking further ahead, and maybe even faster inference in some scenarios. It's still early days, but it's an interesting direction.
Okay, so this combination of MOE, aggressive compression, smarter data curation, accessible fine-tuning with PEFT, and maybe new prediction methods, that's the secret sauce enabling this open source wave.
That's a huge part of it. These efficiency breakthroughs make it feasible for smaller teams, researchers, and companies outside the absolute top tier to work with, customize, and deploy incredibly powerful models. And this efficiency directly fuels the next big trend we're seeing.
Which is?
Specialization. If you can work with these models efficiently, you can afford to tailor them for specific jobs. We're moving beyond just giant generalist models towards a diverse ecosystem of specialized ones.
Makes sense. What kinds of specialization are we seeing?
Well, task-specific models are becoming very prominent. We already mentioned several examples.
Coding models.
Right. Models like Qwen 2.5 Coder, claiming support for 92 languages, DeepSeek Coder, Mistral's Cotrol, 80-plus languages, and the Agentic Dovstrol. These are fine-tuned specifically to generate, explain, and debug code, often outperforming generalist models significantly on programming tasks.
Math models, too.
Yes, models like Qwen 2.5 Math, Mistral, DeepSeek Math. These are trained with techniques like chain of thought or tool-integrated reasoning to handle complex mathematical problems step by step.
And multimodality is a huge area of specialization now.
Absolutely. Vision language models are exploding in the open source space. We've seen Qwen VL and the newer Qwen Omni, Llama 3.2 Vision, Google's Gemma 3, DeepSeek VL, Mistral's Mixtral, Microsoft's 5.4 multimodal.
How do they work, generally?
They typically combine a powerful pre-trained language model with a vision encoder like SIGLIP, VIT, or CLIP, which processes the image input. This allows them to understand images and text together, enabling tasks like image captioning, visual question answering, VQA, optical character recognition, OCR, and more complex reasoning about visual content.
And audio processing.
That's another growing area. We're seeing impressive open models for text-to-speech, TTS, including ones capable of multilingual output and voice cloning from very short audio samples like Koki XTTS V2, needing maybe just 6 seconds of audio. Others like MelaTTS focus on real-time performance. OpenVoice V2 and ChatTS are other notable projects in this space.
So specialized models for specific tasks. What other kinds of specialization?
Size and hardware specialization, particularly for edge AI. This is about designing and optimizing models specifically to run on devices with limited compute power, memory, and energy budgets.
Like phones, laptops, smartwatches, IoT devices.
Exactly. The motivations are clear. Lower latency, no round trip to the cloud. Reduce bandwidth costs, enhance privacy and security, data stays on the device, and the ability to function offline.
And how do they achieve this?
It relies heavily on the techniques we discussed. Aggressive quantization, INT4 becomes very attractive here. Knowledge distillation to create smaller student models, pruning and developing inherently lightweight model architectures, like Microsoft's Phi series, which was explicitly designed with this small model efficiency in mind.
You need software support too, right?
Definitely. Frameworks like TensorFlow Lite, PyTorch Mobile, and ONNX Runtime are crucial for deploying these models efficiently on mobile and edge platforms. And hardware is evolving too, with specialized NPUs, neural processing units, appearing in more chips like Synaptics Astra NPU mentioned in some sources.
Give me that quick vignette again, the future vision for edge AI.
Okay, picture this. You're wearing a pair of ordinary-looking smart glasses. Inside, a tiny, highly optimized open-source model, maybe a descendant of 5.4 multimodal, is running entirely on the glasses chip. As you walk around, it's identifying objects, reading signs aloud for you if needed, maybe summarizing a document you glance at all instantly, privately, without needing to connect to the internet. That's the kind of seamless embedded intelligence edge AI promises.
Very cool. One more type of specialization.
Yes, and it's increasingly important. Language and cultural specialization. Early AI development was heavily dominated by English language data and, frankly, Western cultural perspectives, often reflecting biases from so-called weird societies, Western, educated, industrialized, rich, and democratic.
Leading to poor performance or biases when used in other languages or cultural contexts.
Exactly. So adapting models effectively requires more than just translation. It involves approaches like massive multilingual pre-training from the start, which we saw with Alibaba's Qwen 3 covering 119 languages.
But just training on text isn't enough for culture, right?
Right. It also involves culturally specific fine-tuning. This is an active research area. Some interesting approaches, like one called CLCA, Cultural Learning-Based Culture Adaptation, from an April 2025 paper, involve using simulated social interactions to help models learn and align with the values, norms, and communication styles of specific cultures. It's about making AI not just multilingual, but genuinely culturally aware and appropriate.
Fascinating. So we have this wave of powerful, efficient, increasingly specialized open source AI becoming widely accessible. How is this dramatic shift playing out on the bigger global stage? What are the geopolitical and economic impacts?
The impacts are profound and honestly still unfolding. Geopolitically, AI has clearly become a major arena for international competition, particularly between the US and China.
And open source plays a key role here.
It seems to be becoming a strategic differentiator. The US, while having a strong open source community, often sees its frontier, most powerful models developed by companies like OpenAI, Google, Anthropic, kept proprietary, accessed via APIs.
The closed source approach for the cutting edge.
Largely, yes. China, on the other hand, appears to be strategically embracing open source at a national level, or at least its major tech companies are. We've seen rapid releases of powerful open models from Alibaba, Qwen, Baidu, ERNIE announcement, DeepSeek, and others.
Some reports, like Mary Meeker's 2025 AI report cited in our sources, even suggest China is leading the open source race with these recent releases.
Yes, highlighting models like DeepSeek R1, Qwen 32B, and the upcoming ERNIE 4.5 open release. The report also frames open source as a potential monetization threat to the Western proprietary model providers.
Why this strategic push from China towards open source? What are the potential motivations?
It's likely multifaceted. One angle could be circumventing potential U.S. hardware controls or sanctions if you can't easily get the most advanced chips. Maybe you focus on optimizing and distributing the software, the models, that can run well on slightly less advanced or domestically produced hardware.
Make the intelligence layer more accessible.
Right. It also helps rapidly foster a large domestic ecosystem of developers and AI applications. It can project technological influence globally, particularly in the global south, where cost-effective open models might be very attractive. And as DeepSeek highlighted, focusing on efficient architectures and potentially leveraging techniques like distillation might offer a more cost-effective path to high performance compared to training giant proprietary models from scratch every time.
This ties directly into that concept you mentioned earlier, sovereign AI.
Absolutely. Sovereign AI is essentially an extension of data sovereignty into the realm of artificial intelligence. It's about a nation's capability to independently develop, deploy, and manage AI systems that align with its own national interests, laws, values, and strategic goals.
Why is this becoming so important for nations?
Several key reasons. National security is a big one, reducing reliance on foreign AI providers for critical infrastructure or defense. Data privacy and security, keeping sensitive citizen or government data within national borders, complying with regulations like GDPR. Economic competitiveness, fostering domestic AI industries and talent. And cultural preservation, ensuring AI systems are not dominated by foreign biases and can be tuned to local languages, cultures, and values. Regulatory compliance is also easier with domestically controlled systems.
And how does open source AI enable sovereign AI?
It's a massive accelerator. Instead of needing to invest billions in years to train a foundational model from absolute zero, a nation can take a powerful open source model like Llama, Mistral, or Qwen, and then fine-tune it, adapt it, and deploy it using its own data and infrastructure. It provides a huge head start, fostering autonomy without requiring frontier R&D capabilities immediately.
You see this playing out.
Definitely. The European Union, for example, with its EU AI Act, emphasizing trustworthy AI, has implicitly and explicitly supported European players like Mistral AI. Investments in computing infrastructure, like Denmark's Qwen supercomputer, are also part of enabling this. China's strategy, with state investment in domestic champions and leveraging open source, clearly aligns with building self-reliance in AI. Open source also helps decentralize AI talent beyond just Silicon Valley, nurturing expertise globally.
Okay, so major geopolitical shifts. What about the economic impact? How is this disrupting existing business models?
It's putting significant pressure on the business models of proprietary AI providers who primarily sell API access to their large models.
Why would companies switch from, say, OpenAI's API to an open source model?
Several compelling reasons highlighted in our sources. Cost savings is often the biggest driver. Running an open model locally or on cheaper cloud instances can be dramatically less expensive than paying per token for a premium API, especially at scale. Customization and control are huge. You can fine-tune an open model on your own private sensitive data without sending it outside your organization. You can host it on-premises or in your private cloud for maximum security and privacy. And you avoid vendor lock-in. You're not tied to a single provider's roadmap, pricing changes, or potential discontinuation of a model version.
So how are the proprietary players responding to this pressure?
They seem to be focusing on a few key areas, pushing the absolute frontier of capability with even larger, more powerful models that open source struggles to match immediately due to resource constraints. Focusing on enterprise-grade features like enhanced security, reliability, compliance certifications, and support guarantees, which can be harder to get with community-driven open source projects, and offering value-added services and platforms around their models like sophisticated fine-tuning tools, vector databases, agent frameworks, building an ecosystem beyond just the core API.
So the economic model might be shifting. Value moving from the raw general intelligence, which gets commoditized by open source, towards specialization, end-to-end solutions, and enterprise tooling.
That seems to be the trend. Open source commoditizes the base layer, forcing value creation further up the stack.
And what about opportunities for smaller players, startups, SMEs?
This is where open source is incredibly empowering. It dramatically lowers the R&D costs and barriers to entry. Startups can leverage powerful base models without massive upfront investment, allowing them to focus their resources on building innovative niche applications or providing specialized services. They can be more agile, customize models deeply for specific customer needs. Meta's Llama startup program is an example of trying to foster this. It's a democratization of AI capabilities, meaning innovation is less likely to be monopolized by just a few giants.
Yeah, and the impact on researchers and academia.
It's been transformative. They now have unprecedented access to state-of-the-art models, not just APIs, but the actual weights, allowing for deep investigation into how these models work, their limitations, biases, safety properties. Things like interpretability research become much more feasible.
You can actually dissect the model.
Exactly. It enhances collaboration and reproducibility, with platforms like Hugging Face becoming central hubs for sharing models, code, and data sets. It opens up new avenues of study, like comparing models developed with different techniques or data from different regions. And it's hugely beneficial for education, giving students hands-on experience with cutting-edge AI.
Are there downsides for researchers too?
The main challenge remains access to sufficient compute resources for large-scale experiments or training, even with open models. And there's the risk of inheriting and propagating biases present in the open models or the large, often uncurated data sets they were trained on.
Okay, so this wave brings immense opportunities, faster innovation, transparency, customization, democratization.
Yeah.
But you called it a dual-edged sword. Let's talk about the other edge, the risks and challenges.
Yes, this accessibility and modifiability cuts both ways. The same openness that fuels innovation also lowers the barrier for misuse. Misinformation and disinformation campaigns become easier to generate at scale with tailored, persuasive content.
And deepfakes.
Deepfakes and synthetic media are a major concern. Open source models for image, video, and audio generation make it easier to fabricate realistic fake content. We've seen examples involving public figures like Taylor Swift. This can be used for propaganda, influence operations, think state-sponsored campaigns like doppelganger or spamouflage, generating fake news sites or social media accounts, but also for personal harassment or fraud.
And basic spam, and scams get supercharged too.
Absolutely. Another risk is that the very openness allows users to intentionally bypass safety measures built into the models. People fine-tune open models specifically to remove safeguards against generating harmful, biased, or illegal content. This is often referred to as jailbreaking a model. Some sources noted that even powerful models like DeepSeek R1 could be susceptible to this if not carefully managed.
Beyond misinformation, are there direct security risks?
Yes. There's concern that AI, including open models, could be used to accelerate malware development. We've seen proof-of-concept examples like GhostGPT. AI could also enhance phishing attacks by generating highly personalized and convincing scam messages, help attackers find software vulnerabilities more quickly, or even assist in orchestrating complex cyber attacks.
And risks from the open source supply chain itself.
That's another angle. There's the potential risk of malicious code being hidden within the model files or associated code repositories. The common practice of using trust remote code, true, when loading models from hubs like Hugging Face carries inherent risks if the source isn't thoroughly vetted.
Okay, those are immediate harms.
Yeah.
But you mentioned a more fundamental long-term threat earlier related to data, the AI slop problem.
Yes, this is a really critical issue that the entire field is grappling with, both open and closed source. AI slop refers to the increasing pollution of the internet, which is the primary source of training data for most large models, with vast amounts of low-quality, often repetitive, sometimes factually incorrect content generated by other AIs.
So AI is eating its own digital tail.
In a way, yes. And the fear is that if future generations of AI models are trained predominantly on this synthetic slop data,
They'll get worse.
they risk entering a cycle of degradation known as model collapse. Researchers use various terms: digital cannibalism, the digital Ouroboros, even comparing it to a prion disease for AI.
What actually happens in model collapse?
Models trained on AI-generated data tend to amplify existing biases and errors. They lose diversity, forgetting information about less common concepts or rare events that were present in the original human data, but get smoothed over by the AI generators. Their outputs can become less accurate, less coherent, and sort of converge towards an average, losing the richness and nuance of human-generated text and knowledge. It fundamentally threatens the long-term improvement of AI models if we can't ensure the quality and provenance of their training data.
And that DeepSeek R1 training data controversy we discussed, the allegations of training on proprietary model outputs, that seems directly related to this issue of data provenance and potential slop.
It absolutely is. Whether or not those specific allegations are fully true, the situation highlights the immense pressure to achieve state-of-the-art performance, the temptation to use easily available synthetic data, even if it violates terms of service, and the generally murky ethics and lack of transparency around the data used to train many models, both open and closed. It underscores the urgent need for better methods of tracking data provenance and ensuring the integrity of training sets going forward.
A huge challenge. What about ethical oversight and accountability in this decentralized open world?
That's another tough one. When anyone can download, modify, fine-tune, and redistribute a model, who is responsible if it's used to cause harm? It leads to a diffusion of responsibility. It's also much harder to enforce consistent ethical guidelines or value alignment across thousands of independent developers and users adapting these models in different ways.
Can licensing help here? Like DeepSeek's use restrictions?
It's one approach, trying to bake ethical use clauses into the license. But enforcing those restrictions globally across countless users is incredibly difficult, and some argue it goes against the core principles of open source. It's an ongoing debate. The community is exploring safety benchmarks, auditing procedures, and red teaming efforts. But robust solutions for decentralized ethical governance are still elusive.
And just the practicalities of open source.
Yeah, for enterprise adoption especially, there can be hurdles. Quality can be inconsistent across different open source projects. Some models might be abandoned or poorly maintained, leaving users vulnerable. Getting reliable, guaranteed support can be difficult compared to commercial offerings. These are practical challenges the ecosystem is still working through.
Okay, we've covered the excitement, the tech, the global shifts, the massive opportunities, and some pretty significant risks. Where does this leave us? What's the overall future outlook for this new wave of open source AI?
Well, the trajectory seems clear. Open source models are rapidly closing the performance gap with proprietary ones across a wide range of tasks. In some areas, particularly when considering efficiency or specialization, they might already be achieving parity or even superiority for specific use cases.
So will open source completely take over?
Yeah.
The proprietary models disappear?
I think that's unlikely, at least in the near term. The most probable future, based on our sources and current trends, looks like a hybrid, symbiotic ecosystem.
How so?
Symbiotic? Yeah. Open source models will likely continue to gain ground, becoming the default choice for many mainstream applications, research, education, and specialized tasks where cost, customizability, transparency, and control are paramount. They are the great democratizing force.
But proprietary models still have a role.
Absolutely. The large, well-resourced proprietary labs will likely continue to push the absolute bleeding edge of scale and capability training the next truly massive, multi-trillion parameter models. They'll also likely maintain an edge in enterprise features, polish, and integrated platforms for a while.
And they learn from each other.
Definitely. Innovations in open source, like MoE becoming mainstream, push proprietary developers. Breakthroughs announced by proprietary labs often inspire open source implementations. Techniques flow back and forth. Users will likely mix and match, maybe using an open model for routine tasks, but calling a proprietary API for a particularly complex problem. Open source drives accessibility and competition. Proprietary drives massive investment in frontier research. They coexist and push each other.
Okay, a hybrid future. What are the biggest unsolved problems or the next frontiers specifically for the open source community to tackle to really fulfill its potential?
There are several big ones. First, tackling that AI slop and data integrity problem head-on. This means developing robust methods to detect and filter low-quality AI-generated content from training data. It also means investing in creating and curating high-quality, diverse, ethically sourced open datasets with transparent provenance and establishing standards for data validation.
Data quality is paramount. What else?
Scalable and robust safety and alignment. How do we ensure open models behave safely and align with human values, especially when they can be easily modified? We need better techniques for building in resilience to jailbreaking, more research into model interpretability, explainable AI or XAI, and potentially community-driven mechanisms for auditing, red teaming, and perhaps even certifying models based on safety criteria.
Making powerful multimodal models as accessible as text models.
Yes, improving the efficiency, ease of fine-tuning, and deployment of large, capable multimodal models is a key frontier. Right now, they're often more complex to work with than text-only models.
What about more advanced capabilities?
Pushing towards more sophisticated agentic AI and reasoning in open source, models that can reliably perform complex, multi-step tasks, interact robustly with tools and APIs, and exhibit deeper reasoning. DeepSeek R1 was a step, but truly capable open agents are still a major goal.
And the sustainability of open source itself.
Finding sustainable funded models beyond corporate sponsorship or volunteer efforts for the long-term maintenance and development of critical open source AI projects is crucial. Coupled with that is developing effective decentralized governance mechanisms to manage quality, ethics, and responsible release strategies within these large communities.
Hardware needs to keep up too.
Yes, better hardware-software co-design. Ensuring open-source software frameworks like VLLM or tools like UCCL for distributed training work efficiently across diverse hardware is important. And ideally, fostering more open standards for AI hardware itself could benefit the entire ecosystem.
And the ultimate AI challenge.
The long-term grand challenge for all AI, open or closed, moving beyond sophisticated pattern matching towards deeper semantic understanding, common sense reasoning, and true generalization. Areas like multi-token prediction might offer small steps, but it's a huge leap.
And finally, ethics and inclusion.
Continuing to focus on inclusive development practices, mitigating biases, adapting models effectively for diverse languages and cultures, like that cultural alignment research, and building tools to support cross-cultural understanding and fairness are perpetual critical tasks.
Okay, let's try to synthesize this whirlwind tour. The new wave of open source AI represents a fundamental shift. It's about sharing the intelligence, the weights, not just the tools.
Right. And it's powered by technical breakthroughs in efficiency like MoE, quantization, PEFT, and a drive towards specialization across tasks, hardware sizes, and languages cultures.
The result is a dramatic democratization and decentralization of AI power, impacting startups, researchers, and even nations pursuing sovereign AI goals.
This is shaking up geopolitics, particularly the US-China dynamic, and disrupting traditional economic models by challenging proprietary API providers and creating value in new areas like customization and tooling.
But, as we stressed, it's a dual-edged sword. Alongside the incredible opportunities for innovation and transparency come significant risks. Misuse for disinformation or cyber attacks, the systemic threat of data pollution, AI slop, and model collapse underscored by controversies around training data provenance and the inherent challenges of ethical oversight and accountability in a decentralized ecosystem.
The future seems hybrid, a complex interplay of open and closed approaches, competition, and symbiosis. The ultimate success and positive impact of this powerful open wave really hinge on how effectively the global community developers, researchers, companies, policymakers can navigate and mitigate these substantial risks.
So, bringing it down to brass tacks. For you listening right now, maybe you're a founder, a developer, perhaps involved in policy. What are some actionable takeaways?
Yeah.
What should you consider doing, say, this quarter based on what we've discussed?
Okay, if you're building something, definitely consider piloting an open source model first. Try customizing it for your specific needs using PEFT before you automatically reach for a paid proprietary API. The cost savings and control can be substantial.
Explore the specialized models, too.
Absolutely. Don't just grab a generic model if there's a specialized open one for coding, math, or vision that might perform much better on your task. And think about optimizing for edge deployment early if your application could benefit from on-device processing.
And the licenses.
Critically important. Scrutinize the licenses carefully. Remember our spectrum. Open doesn't always mean Apache 2.0 free-for-all. Understand the restrictions, especially around commercial use, user limits, or prohibited applications before you build on top of a model. And maybe consider contributing back to open projects focused on safety, data quality, or documentation. Strengthening the ecosystem benefits everyone.
Good advice. And for policymakers listening.
I'd say first, seriously consider how sovereign AI strategies can strategically leverage open source models as an accelerator for building national capacity and autonomy, rather than seeing open source solely as a risk.
Focus on the data problem.
Yes, urgently focus on promoting standards and solutions for data integrity and provenance. That AI slop and model collapse issue is a systemic risk that needs attention. Support research into robust safety, alignment, and auditing techniques specifically for open models as they present unique challenges. And finally, engage proactively in international dialogues to establish norms and best practices for the responsible development and deployment of powerful open AI systems globally.
Okay, practical steps for different folks.
Right.
To wrap up, let's end with that provocative thought. We've talked a lot about the risks of AI slop and model collapse.
Right. The idea that training future AI on the output of current AI could lead to degradation.
So here's the thought. If the very foundation for training all future AI models, open or closed, is potentially becoming polluted and less diverse because the internet is filling up with synthetic content, are we inadvertently poisoning the well? Could the very success of current AI models be limiting our ability to build genuinely more intelligent and capable systems in the future?
That is definitely a question keeping many AI researchers up at night. How do we ensure progress when the data landscape itself is being fundamentally altered by the technology we're creating? It's a profound challenge.
Indeed. A lot to mull over there. Maybe that data integrity crisis and potential solutions could be the focus of a future deep dive.
The field is certainly moving fast enough to warrant it. There's always more to unpack.
Absolutely. If you have questions about today's topic or suggestions for future deep dives, please do send them our way. Thanks so much for joining us on this exploration of the new wave of open source AI.